This is Shakil Ahmed. Welcome to my channel. In this video, we will discuss about ROC analysis. ROC means receiver operating characteristic that is used to evaluate the model performance. Basically, when we have a qualitative variable, binary variable, and a set of predictors, then we see how the predictors are uh, well in predicting the outcome, basically the binary outcome. So this is widely used in diagnostic studies where different biomarkers are, uh, we can say the exposures, uh, we can see the effect of exposure on outcome using ROC analysis. We can say that how a biomarker is predicting the presence or absence of disease uh, in individuals. So for that purpose, we can do the ROC analysis. So there are a lot various purposes of ROC analysis, including uh, its ability to distinguish between disease versus non-disease, and it also provides a simple performance metrics of predictive models. We already discussed. In today's world, it is widely used in machine learning models to assess or evaluate the performance of models. And it is also used to find the threshold value of a predictor of an exposure in predicting the outcome and usually disease. For example, we can say that blood pressure predicts the absence or presence of um, cardiovascular disease in a patient, then we need to decide which will be the what will be the cut point for blood pressure. That if the blood pressure of a person exceeds that cut point, we say that the person has a myocardial infarction, or he or she has a cardiovascular disease. So this is important to obtain a optimal cut point, which increase the area under the receiver operating characteristic. So we discuss about area under the operating characteristic, receiver operating characteristic, and how we can get this in R. I have just imported a part of data set from National Health and Nutrition and Examination Survey only for the cycle 7, right? That is 2017 and 18. So you can see the number of observations and number of variables. We have only 9,000 observations, around 962 variables, and we are just going to fit a logistic regression model. For that we need uh, uh, these packages. I think Heaven packages are just used to import data from Strata, and the ROCR is used for ROC analysis. So we can just run a GLM with chronic condition as dependent variable, or the response variable, and income, age, and sex are the uh, covariates. We can say if we are interested in if on assessing the effect of income or chronic condition, then we are taking age and sex as confounding variables to balance the effect of income on chronic condition. So we can find the sensitivity and specificity using the prediction command, and you can see the true positive and false positive values. These are the performance measures. You can just see how the performance values are. These are basically the true positive rate and false positive rate. And we can just plot the receiver operating characteristic curve. This is the curve which is plotted uh, for false positive rate versus true positive rate. False positive rate is taken on x-axis and true positive rate is taken on y-axis. And this is the plot for different combination, basically for different values where we are getting this much uh, false positive rate and this much true positive rate. And what is the area under this curve? That is important. That is called area under the receiver operating characteristic curve. So what is the value of AUC? We can find the area under the curve. You can just run a AB line, that is a 45-degree line starting from 0 to 1. And if this line lies below this 45-degree line, then we if this line is closer to this line, then it means the prediction is totally at the random, mean the prediction is not better. And when this line go far beyond above this 45-degree line, we can say that the area under the curve is better, and we can say that the predictors are good and in predicting the response. So we have another method for obtaining AUC, that is you can find the area under the curve. That is 0.8986. That means around 90% area lies around the under the ROC curve. So this is a good model. Basically, we can say that income, age, and sex are uh, contributing or predicting around 90% of the uh, chronic condition. So we can make the plot again, and now we will see a threshold. That is the threshold of probability, basically probability of predicting a positive case. Probability of, you can say, y is equal to 1. That is 0.154. If the value of the probability of any individual is greater than this value, then we declare that the person has the disease. Otherwise, we can say that the person does not have the disease. So this is the threshold point, and this threshold point is obtained with the specificity a 0.745, that is around here, and the specificity, that is 0.91. So this is the cut point. So that's a brief introduction of ROC curve. We have I will try to make some other videos using survey weighted data. So thank you for watching.